Good morning, sir. Alukdar, sir, good morning.
Good morning. Good morning. Am I audible?
Yes, sir, you are audible.
तैमूर आपका आवाज अभी भी बहुत लो है.
Now,
Now
sir?
it is okay. Now it is okay.
Okay.
Earlier it was too low. I think the volume was very low.
Yes, sir. First day the same problem was there.
हाँ, वही तो मैं आपको बताया था ना.
Yes,
The
sir.
director testimony, because at that time,
Yes, sir.
since you were in the middle of a program, na,
Yes, sir. It was not looking
every
good.
chance that many things may be going in a different direction. Na.
Yes, sir. Sir, shall I proceed now? It's 9:30.
Just let me check. I think still that means I don't have any participant, na?
No, 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 sir. Participants are in YouTube. No
Acha,
participants
okay.
in the
Okay, so
just
no
chat
problem.
box.
I have no issue. Yeah.
Okay, sir. Participants have already joined.
Acha.
Uh, Hello, everyone. I extend my warm welcome to the participants on the fourth day of 1 week long ATAL FDP on Information and Communication Technologies for Smart City Applications, ICT for Smart 2021, organized by Department of Electronics and Communication Engineering, National Institute of Technology, Silchar, and sponsored by AICT New Delhi under ATAL FDP scheme. It is my privilege to welcome the first invited speaker of today's session, Professor F.A. Talukdar from our own department. Fazal Ahmed Talukdar obtained his BE from Regional Engineering College, Silchar, now NIT Silchar in 1987. He obtained his MTech in 1993 and PhD in 2003 from Indian Institute of Technology, Delhi and Jadavpur University, respectively. He joined the Regional Engineering College Silchar as a lecturer in April 1991, became an assistant professor in March 1996, rose to the level of professor in May 2006. He was elevated to the level of a professor HAG in 2018. Prior to joining Regional Engineering College Silchar, he was a lecturer in the Technical Education Department of the Government of Assam during August 1988 to March 1991. During 2006, he was a visiting scholar in the University of Illinois at Chicago, USA. He was head of the Department of Electronics and Communication Engineering from August 2006 to April 2006, and again from April 2018 to March 2020. He was the first Dean Alumni Relations during 2012-13 and Dean Academic Affairs during 2013-15. During July 2004 to June 2009, he was the registrar of NIT Silchar. He also held the post of Deputy Registrar Accounts during March 2005 to August 2007. Besides this, he worked in many other committees of the institute. Currently, he is also a member of PRSG of Ministry of Electronics and Information Technology and Performance Auditor of NIT Mizoram and NIT Sikkim under TechIP 3. He is a fellow of Institution of Engineers, life member of IST, and senior member of IEEE. His research interests are signal processing, communication, power electronics, and analog circuit design. It is an honor for me in welcoming and inviting you, Professor Talukdar, to start the session.
Uh, thank you so much, Dr. Khan, that is for this wonderful introduction. So should I now start sharing my?
Yes, sir, you can
Yeah. Okay.
start your presentation.
Is my screen visible to?
Yes, sir, it is visible. Let
Okay. Yeah.
slide slide
Mm.
show. Yes, sir. Okay. Yes, sir.
Uh, Good morning, everybody. Just at the beginning, that means I just extend my that means the welcome to all the participants, the distinguished speakers, on behalf of the Department of Electronics and Communication Engineering, National Institute of that means the Technology, Silchar. I'm really that means honored to share some of the thoughts which are associated with that with the smart city implementation, and most likely the way that means the I will be that means the communicating and sharing my that means the thought process will be slightly different from the kind of that means the presentation and lectures that you have that means the experience in the last 3 days. Because what I observed in the last 3 days is that most of the presentation is that means in a specific core research area of smart city applications. And I do understand that the audience is that means they're having a heterogeneous background. They are from electrical, they are from electronics, communication engineering, computer science, civil engineering, and many other that means the branches of engineering and science. So having a that means a very that means a specific research topic may sometimes be that means a little bit that means a boring. So just to make it change, I have that means just change the track, and I will try to that means connect to you is something that means which is in a that means a very general term. Okay, so the topic that means on which I will speak for next 1 hour or so will be role of communication technologies in smart city implementation. And Dr. Khan has that means already given an introduction that means about me. I'm Faisal Ahmed Talukdar. I am a professor in the Department of Electronics and Communication Engineering, National Institute of Technology, Silchar. Okay, just let me begin that means my presentation. Before that means I really go into the role of that means the communication technology in implementation of smart city. What I the first thing that means I wish to share you is that how do you define that means really that means a smart city. Okay, what you observe is that a developed urban area that creates sustainable economic development and high quality of life by excelling in multiple key areas: economy, mobility, environment, people, living, and government. Excelling in these key areas can be done so through strong human capital, social capital, and ICT infrastructure. If you happen to look into most of the urban areas in our country, if something cannot be that means done on a very that means urgent scale, then most likely in 10 to 15 years time they will be just unlivable. And the reason that means for which our cities are that means with lot of that means population, because the cities offer a better place of that means earning the livelihood. So most of the people who are that means initially that means residing and who are that means born in urban areas had to that means migrate to cities. And the cities are having a limited capability. And so the entire urban infrastructure is now tremendously that means pressured. And what is required is that until and unless that means that we do something that means on an immediate scale, then the entire that means urban infrastructure is that bound to collapse. So here comes the concept of that means the smart city. So when Sri Narendra Modi ji that means took about the prime ministership of the country in 2014, he thought of that means the making our city that means the livable. And so what happened is that the smart city project is undertaken by the government of India that means across the country. And initially that means the plan is to that means identify and that means implement the smart city project in in a limited number of cities. So what you can that means observe in case of a smart city is that it is primarily that means the human capital, social capital, and or ICT infrastructure. Subsequently, that means what you will see and what I will that means share with you is that, and possibly that means in the last that means that what you have observed is that smart city is nothing but integration of that means the very high-end technologies to improve the lifestyle of people that means who are living in urban areas. And the area itself is that means facing a great that means difficulty in that means coping up with the ever increasing influx of population. Okay, just if you happen to that means look into that means what a smart city that means should have. It should have smart buildings, should have smart water, smart energy, smart integration, smart public service, as well as that means a smart mobility. These are that means some of the that means the key things which are that means required to be implemented if you are to make a general city that means into a that means smart city. Unless that means you will be able to that means accomplish all of them that means one by one or that means together over a time frame. The concept of that means the smart city will be defeated. The most important part here is that above all these things, you need to have smart people who will be that means the living and managing the smart cities. Okay, so if you happen to that means look into your smart city, a smart city framework can be that means thought of to be something like this. We need to have environment friendly design of buildings. We have to have next generation vehicle center. Most of the urban areas are already facing the parking place crunch. So if you likely to that means visit a crowded area in a city, most likely you need to park your car at least that means the 1 or 2 kilometer away from that location, because there is not that much of a parking space which is available nearby. So what is very important in the smart city framework is the next generation vehicle center. What we can do is that means the amount of wind that can be present in a that means a city area can also be that means the explored, and can also be that means the exploited to convert into that means the energy. So what we can do is that we can have a that means the wind farm concept, which should also be a part of your smart city framework. Similarly, what you can do is that we have that means the mega solar, we have that means a mega solar plant, the smart houses, biomass fuel, the small and medium sized smart buildings, multi energy stations. You are having the solar panels, you are having your smart house, multi energy stations. All these things are that means a part of your smart city, that means the framework. So if you can that means include everything in the smart city framework, then definitely what is required is that we need to have a smart infrastructure, we need to have smart governance, we need to have smart living, we need to have smart technology, as well as your that is a smart economy. Okay. Now there are various kind of that means the definitions which are there for a that means the smart city. And there is no that means the unique and universally that means the accepted definition of what is really that means the smart city. A city equipped with a basic infrastructure to give a decent quality of life, a clean and sustainable environment through application of some smart solutions. This includes public information, grievance redressal, electronic service delivery, citizens engagement, waste to energy and fuel, waste to that means the compost, 100% treatment of wastewater, smart meters and management monitoring water quality, renewable source of energy, efficient energy and green buildings, smart parking, intelligent traffic management systems. If we have to that means the identify almost that means the each and that means the every function of a that means the city life, and then try to that means the make it smart through the application of technology, and possibly that means the only then we will be that means the able to make it possible to bring that means the perceptible change in the life of the residents of a city. Okay, so the moment that means that we combine that means all of them together. So what you can say is that we are having we are having a smart living, smart economy, smart people, smart governance, smart mobility, and smart environment. And what you will observe is that they are in a that means a cyclic fashion, and they cannot that means exist in isolation or in silos. They have to be that means implemented that means together in unison, and only then that means it is possible to convert a that means smart city. But the problem here is that the cities were initially developed only for a that means a limited population, and thereafter that means it undergo lot of that means organic and inorganic that means expansion. So implementing the smart city in every aspect of an existing city that means really very difficult, and that means tough. But the way that means the scientists and engineers have been that means changing the face of technology and changing the way that means we think and work. It is possible that even the existing cities can also be that means fully converted into smart cities that means over a period of time. Okay. Now gradually that means I am moving towards that means how the communication technology, or that means what or an information technology can be that means used to make it city smart. So a smart city is one that has a digital technology embedded across all city functions. Last 30 years or so has that means made a tremendous impact in our that means the life, the way that means the we think, because the technology has that means the penetrated in each and that means the every segment of our life. So why not that means the try to use technology to change the functioning of a city, because the technology is now that means the almost that means the all pervasive. And if this all pervasive technology can be that means the deployed or can be that means the integrated with the city functions, then surely what you will find is that you will find that the quality of life of people living in urban area can be that means the improved in a very decent manner. So the meaning of a smart city is equipped with basic infrastructure to give a decent quality of life and clean and livable environment to live smarter. Okay. And what we do that means the in case the smart city uses digital technology and information and communication technologies to better quality and performance of its citizens by effectively and actively engaging its citizens. The smart city includes government services, transport, traffic management, energy, healthcare, water, and waste. The smart city applications are major goal of improving the management and transforming the urban areas. The major technological, economic, and environmental changes have generated interest in smart cities. Okay. Now, just look into so we are the away from your that is the definition part of what is called your that is the smart cities, right? So now let us see that means how the communication technology can be deployed so that the cities become that means the smart cities. This is a representation where that means what we find is that means we are having your that means the residences, we are having smart car parking, we are having your if your that means the city is that means the nearby to that of a that means the sea, then it has the chance or it is vulnerable from that means the enemy, and the enemy may that means the use the sea route to that means the enter into your city. Okay. So what is there is that if we happen to that means the look into this particular that means the representation, what we find is that the every function of the urban area is now that means the represented here. What we can do is that we are having that the smart waste management. We are having a that means the smart grid. We are having that means the smart meters. We are having smart people. We are having that means the smart transportation. And then we are having that means the smart houses. We are having the smart sea that means the monitoring. But the question is that means how are you that means going to integrate, and how are you that means going to that means combine them together. So if you happen to that means look into this one, then what you will find is that we are having a that means the box which is there in the inside. And in that particular box, what you will find is that we are having that means several acronyms which are called LTC, NFC, WiMAX, 6LoWPAN, LoRaWAN, Zigbee, Bluetooth, LTE, Z-Wave, and Wi-Fi. So these are the kind of that means the communication technologies that means the which are identified and which are being implemented, deployed that means the across many cities, so that the most of the city functions can be that means made digital and can be that means combined together, can be controlled from a that means a single location. Okay, so if you are having a that means uh, a smart transportation systems where every vehicles will be having that means some kind of that means the communication devices, and these communication devices can be that means made a two-way communication with the nearby that means the control center. So if there is a traffic congestion that means in a particular area, then such vehicles that means can be that means advised to take a that means the detour, so that your that means the traffic congestion is not that means the further increased. So similarly, that means for many of the that means the other that means the such functions, what we can do that means that we can very easily that means that deploy the communication technologies and make the life of that city dwellers much more that means comfortable. Such kind of that means the functionalities cannot be that means done manually, and it will be that means very difficult. And what we observe is that most of our traditional cities who are being run by municipal corporation and other agencies, the civic amenities and civic facilities are that means really that means in a bad shape. Even though their services can be that means improved, but they lack the that means the technology. So the concept behind the smart city project is to take a holistic approach and try to find out that means how the communication and information technology can be deployed, can be that means leveraged, so that your city life becomes that means much more comfortable, it becomes that means much more livable. Okay. Now, there are a lot of research that means which are going on across the world on smart city that means the implementation. And this is the taxonomy of the various kind of that means the researches that means the which are that means the going on across the world. If you happen to that means the look into some of the that means the keyword, what you find is that there are a lot of that means the mention of that means the communication technology and as well as that means the information technology for smart city implementation. So you just that means that cannot have a smart city until and unless that means that you extensively deploy information and that means the communication technology. So if you just to make the life of the population of a that means the city more comfortable and that means less tedious, what we have to do that means we have to that means ensure that there is that means a lot of communication and information technology which are at the back end call of city management, so that the city can run that means much more in a in a much that means a better manner. Okay. Now the kind of technology that means that is there, that I consider that means in one of the that means the earlier slides. Just that means I will try to that means make, because since the audience itself is having a that means a very heterogeneous background. So what is to be done is that we have to that means make a comparison of what are the that means the various modern communication technologies which can be that means deployed in smart cities. Okay, this table itself will show you a summary of the various kind of that means the technologies, and they are that means the basic features. So what is Bluetooth is a technology that means which is almost universally known to that means now almost everybody. Z-Wave, IR, Zigbee, LoRaWAN are that means these are the technologies, but they are that means not that means as well known as that of that means Bluetooth. Okay. Similarly, Wi-Fi is also that means very much common and very much that means well known to that means everybody. WiMAX is a technology which is that means really very similar to that of in operation to that of that means Wi-Fi, but has some very that means superior features compared to that of the Wi-Fi. But unfortunately, that means the WiMAX technology so far that means has not been able to make a large penetration in its application, at least that means in our country. And there are that means two more things. What is called that means LTE, long-term evolution, what we usually call that means in our country as that means the 4G. Most of the your that means the network, telecom network nowadays are a 4G network, and the underlying technology that means which is deployed is what is called that means the LTE. Now there is one more thing which is called that means the technology which is called that means the LTEA. A stands for advanced. Here the LTE doesn't have a your backward integrability. Like if you are having a that means the 3G network or a 3G that means the device, they cannot be directly that means integrated with that of that means the your LTE. But the LTE advanced has your that means the back end compatibility is that means the built in. So if you just consider about that means what are the communication technologies which can be that means used for smart city application, okay, then what you can do is that means the Bluetooth. The standard or the governing bodies is IEEE. The standard is your, that means the IEEE 802.15.1. Generally, it operates in the range of around, that means the 2.4 gigahertz, and it has a, that means the range of approximately around 1 to, that means the 100 meter. In a densely populated urban area, within a 100-meter range, there are a lot of buildings, there are a lot of infrastructure, and there are, that means a lot of, that means the other things where the Bluetooth can also be, that means the, taken as a, that means the technology to implement smart city applications. Generally, what happens is that the Bluetooth offers a data rate of, that means the 1 Mbps, and the communication topology that we follow is a point to point one. In case of Z-Wave, okay, it operates at 900 megahertz. The range is approximately around 100 meter. The data rate is, that means the much lower, roughly around say 9.6 to 100 kbps. Okay, we can have a, that means your topology, which is a star, a cluster, as well as a mesh. Okay. Zigbee is a communication which is again, that means the standardized by IEEE 802.15 dot, that means the 4. It's operated for 2.4 gigahertz. It has a range of approximately 10 to, that means the 20 meter. Okay. So in a building, in a building, or in a, that means the house, sorry, all sort of, that means the communications can also be, that means carried out with the help of your Zigbee technologies. It also, that means offers a decent data rate of 250 kbps. Okay, the topology that is, that means the followed is a mesh one. LoRaWAN is a low power wide area network. The governing body is LoRa Alliance. It operates, that means the 867 to 869 megahertz in Europe. Of course, it has a, that means the larger range, roughly around say 2 to, that means the 5 kilometer. Definitely, it has a, that means a much lower, that means the data rate compared to the other ones. Okay, here what you find is that the data rate is approximately around 290 bps to 50 kilo bps. The topology that we follow is a star one. Wi-Fi is, that means the known to, that means the almost everybody, and in an urban area, almost, that means the nowadays everybody, that means uses Wi-Fi in one form or the other form. Okay, so the governing standard is IEEE 802.11 A, B, G, and N. The frequency range on which it will work is 2.4 gigahertz, 3.6 gigahertz, 4.9 gigahertz, 5 gigahertz, 5 point, that means the 9 gigahertz. It has a, that means the decent range of around say 100 meter. Okay, and it has a data rate very large, 1 to, that means a 54 that Mbps, and generally the topology that means that we is called is a starred topology. The next one is what is called, that means the WiMAX. The governing body is 3GPP. Okay, the operating frequency is 2 gigahertz, 5 gigahertz, as well as your 10 gigahertz. The range is approximately 50 kilometer. Okay, so your data rate is, that means a very high. It is around 75, that means the Mbps, and it works on point to point, point to multi point, as well as, that means the mesh topology. And in case of, that means the LTE, again the governing body is 3GPP. It works in 2.5 gigahertz, 5 gigahertz, as well as, that means the 10 gigahertz. And the range is, that means approximately around 30 kilometer. The speed available is 300 Mbps at download and 75 Mbps at upload. The topology that we follow is, that means the star. And in LTE advanced, the same, your governing body 3GPP, it is 2 point, that means the 5 gigahertz, 5 gigahertz, 10 gigahertz, 15 gigahertz, and 20 gigahertz. The 30 kilometer is approximately the range of the communication, and it is generally, that means the your 1 gigabyte download and around half gigabyte your upload. Okay, 1 Gbps download and 500 Mbps your upload. It works on that means a point-to-point technology. So the moment that means we consider about deploying the communication technologies for smart city application, we have to that means explore the possibility of that means this basket of technologies that means which are in operation. They are all that means the commercial technology that means nowadays, but there may not be that means having widespread application. Some of the technology that means may not be having that means a widespread technology or your application. So what is required is that we need to find out based on the requirement which technology in smart city application will be that means the very important. Okay, so here that means the in this particular that means the slide you can see that we have a taxonomy based on communication and networking aspects of that means your smart cities. Okay, here what we consider is that we consider the same as future and emerging technologies. We consider the same as modern communication technologies, and then we have the IEEE wireless technology standards. The objectives are also there, the network classes as well as the mode of operation. Okay, so what you observe is that the future and that means the emergent technologies that will find that means a major application in smart cities will be software defined wireless networking technologies. We can have network function that means a visualization that can also be that means are deployed. We can have that means a visible that means a light communication. We have cognitive radio networks. We have the green communication, 6LoWPAN, THRAD, Sigfox, null and near field communication. Some of these technologies are that means the already that means the established. Some of them are that means the in the development process and likely to be that deployed on a commercial scale that means the in a very short time. So what happens is that the moment that means that we talk about the communication technology that means that will be required. So what we can do that means either we can deploy the existing technologies because there are several challenges of deploying a communication technology for smart cities. In congested that means the business district, what you find is that there are that means the high rise buildings. So signal propagation that means that becomes very large, very difficult. And so what happens is that you need to find out that means the alternative means. Traditional communication network that means the even may fail in a central business district because there are high rise buildings and there are that means a lot of obstruction. So what is required is that you need to that means consider a particular locality, try to find out that means the which technology is that means a very important or what or yeah, which technology can be suitably deployed for such application. Okay, so in modern communication technologies already that means in the previous slides we have considered Wi-Fi, WiMAX, LTE, LTE-A, Bluetooth, Zigbee as well as Z-Wave and LoRa-1 and the various IEEE standards, wireless technology standards which are deployed are also 802.11, 802.115.1, 802.15.3, 14.15.4, 15.6, and 802.16. So these are the standards which are specified by that means IEEE for specific technologies and that means a specific application. Okay. Now, if you happen to that means look into before deciding about that means what kind of that means the communication technologies you are going to that means deploy. What are your that means the objectives? If your objective is that means the error-free connectivity, then you have to that means look into a particular kind of technologies. If your intention is to have the ultra high spectral efficiency, then definitely that means your objective is your spectral efficiency. Remember that in communication, the most by important and the most that means the costly component is the frequency. So in a smart city application, since you will be deploying that means that too many that means the communication devices and subsequently that means in one of the slides we'll try to that means discuss something which will be regarding that interference management. So what is very important in this particular case is that sometimes that means we need to deploy a technology which is your spectral efficient. Okay. The other aspect or objective that means which can be thought of is that means your high rate data transmission. If the data interchange is that means the most important, then definitely that means you cannot just look into the spectral efficiency and that means the other thing. In case of that means the emergencies or for that means a strategic application in smart city application, a high data rate is that means the desirable. So you need to that means choose the technology which will be supporting the high data rate transmission. If you happen to that means look into the same here, that means what you find is that the data rate is as high as that means the 1 gigabit per second, 1 Gbps per second. And in the lower side, that means what you find is that it may be that means even that means the 9 point, that means the 6 kbps. So when your objective is a high, when your objective is a high data rate, then accordingly that means you have to choose the technology. Our urban areas are really that means a drain on that means our that means the energy resources. The peak load that means usually arises only in the evening, which is roughly around sorry 60 to 70% more than that of the average load. And so what is required is that the electrical power systems that means which are to be designed keeping in mind the peak load requirement. But in the during the daytime, what you will find is that the total load is only that means the 40%. 32 that means the 40% of the peak load. So there is a tremendous amount of that means the investment and a tremendous amount of that means the losses are to be that means the factored into while designing that means the power system. Okay. Now here that means the in communication technologies, the another that means the most important aspect is what is called your low power consumption. Okay. Majority of the communication devices are nowadays that means the mobile or that means the handheld, and they operate on batteries. Okay. And the batteries are having that means a limited that means the your life as well as that means the limited that means the output power delivery capacity. So what is very important is that you need to that means to choose a technology which will that means to consume less amount of power. Otherwise, your that means the communication system may fail. So while that means that you decide about a communication technology for smart city application, you need to that means to give adequate thought either on error-free connectivity, okay, where the reliability of that means a communication is that means a very high, ultra high spectral density, where the spectrum usually that means states what kind of technology you can that means really adopt. And the other two, your high data rate transmission as well as your that means the low power consumption. Okay. So the other issue that means that you have to consider is what is called your that means the network classes. What kind of network? WPAN stands for wireless personal area network. It's a very that means a in computer network or a communication network which is there that means only for a that means a short range. And this is the reason what we can say is that here the communication is done through wirelessly. So what we call is that means the WPAN, wireless that means the personal area network. Or what you can do is that should you deploy WLAN, wireless local area network. That WLAN will be that means much larger that means in its coverage area compared to that of that means WPAN. And the lastly that means you need to consider that means whether your area of operation or area of consideration should be WMAN, wireless metropolitan area network. Okay. If you happen to that means look into the same from the coverage area, the PAN area will be that means very small. The LAN area will be that means a much bigger than of that means a pen, but much smaller that of a your that means a MAN area. Or that means that you have to go for a that means a wireless MAN area. Okay, so all these things are to be that means a kept in mind while that means the thinking about what kind of that means the communication technology that can be that means the deployed. So if you are going for a that means a WPN, then you have to that means to look into certain technologies. Similarly, when you are going into that means a WLAN, then you have to that means go into a different kind of your technology. And if you are to go, if you are deploying a WMAN, then you have to also that means go for entirely that means a different technologies. Okay. Now having that means said about the network classes. Now let us see that means what kind of that means operations, mode of operations is that means another aspect. And primarily what you can observe that means from here is that basically there are that means the two methods of operation which are followed. One is ad hoc, second one is that means the infrastructure. In ad hoc, you may not be exactly having a that means a a permanent communication system. Rather, what you can do is that you have the existing that means the devices which can be configured to carry out the that means the communication process. In case of that means infrastructure based communication, you need to have robust infrastructure or a dedicated infrastructure which will be that means deployed to uh, do the job of communication functionality of a smart city. Sometimes in case of emergency, the your infrastructure based communication becomes inadequate. And in that particular case, what is done is that you need to that means immediately reconfigure the handheld devices to establish a ad hoc communication system. Because the load that means which comes on a communication system in case of emergency or eventuality is that means much larger compared to that of an average load. But all communication systems are usually designed keeping in mind that means an average amount of communication load. And so infrastructure, dedicated infrastructure based communication system is costly. It requires that means a regular maintenance, and after that means a certain period of time, you are required to that means the retire the technology and go for your that means the higher technology. But advantage of that means the ad hoc is that it can be that means the established immediately, and the devices also that means the changes as the technology change. Okay. Now, just to have a comparison of the advantages and disadvantages of that means the modern communication technologies, which are that means identified to be deployed for smart city application. Wi-Fi. The advantages are, as we know that it's the Wi-Fi wireless, so it doesn't require any wire. The user can move, no need to be stick to at one place. Of course, that means within a that means a limited radius. And disadvantages are it suffers from that means a high signal attenuation and limited service radius, less stable compared to wired connections. Because in case of that means a wide similar kind of thing, we always that means a share a channel. WiMAX is high-speed wireless internet connections, and it has a that means a broad coverage area, but it is expensive to install. Unfortunately, this technology that means are not finding much favor commercially in many of the countries. LTE is backwards compatibility and future proofing, high spectrum efficiency, reduce problem of that you're lagging in internet connection. The higher cost due to usage of additional antennas at network base stations for data transmission. So while that means that you have to choose and design a, a network or a technology, recommend a technology, all these things will that means that immediately come into picture. LTE Advanced has high data rate, particularly elevated voice excellence, and it requires that means high cost. The disadvantage is that accessible in confined cities only. Okay. The Bluetooth it is cheap, easy to install, but disadvantages are that it is a short range communication and there are security that means the flaws. Zigbee is a communication that means the which the advantage is that it's a lot of power. It is a power efficient communication system. Okay, collision avoidance is also that means the avoided. Okay, and it is low cost. Okay, so collision means wherever that means that you use a shared channel, the collision is that means the inevitable. So there are that means the technologies, there are protocol that means the which are deployed to minimize or to avoid that means the collision. And as previously that means the, what we have observed is that it is slow compared to that means the other kind of technologies which are identified to work in smart city application. Z-Wave is a bit simpler than that means the Zigbee. And so what happens is that mobility management is that means a very difficult and security flows. So the people almost that means every one of us is that means nowadays that means are using that means a mobile. Okay. So mobility management, where the moment we move away from one cell area to a different cell area, then managing or the hands off is that means a great challenge. So the Z wave that means the suffers from the that means the mobility count. LoRaWAN, the advantage is a low power that means the consumption. It is a secure that means the bidirectional communication, and it is that means the low cost. And what happens is that, but the difficulty is that it is a short range communication. Okay, so this slide is a representation of what are the advantages as well as what are the disadvantages that means that usually encountered in the various kind of that means the communication technologies which are that means the deployed for smart city application. Okay, so having said that, in the last decade a number of that means the cities across the world have that means already adopted the smart city concept, and some are that means the working that means the in that particular direction. So in this particular that means the representative example, we are trying to that means the look into that means the five smart cities of, sorry, four smart cities. One is in Spain, second one is in Canada, third one is in Singapore, and fourth one is in that means the Portugal. And typically the kind of technology that means that they have deployed for smart city implementation. Barcelona in space, the devices that means that they are deploying in IP cameras, wearable devices, traffic monitoring system. Okay, so the business needs automation of the companies, institutions, specific spaces, universities, technological centers, dissemination, and that means the areas. The solution they have that means the found or deployed is fiber optic, 3G, 4G, as well as your that means the, so all these communication technologies are used to achieve the various that means the business needs of a smart city project in Barcelona. And the companies that are involved are that means NC, Cisco, Orange, Telband, UPC, Telefonica, Arbiotica, and that means the T systems. These are the various kind of that means the companies, because no single company or no single technology can that means the solve the problems which are there in a that means the city. And so a variety of technology, a variety of that means the specialized that means the companies are required to that means the come up together to that means the find out a solution for this one. Similarly, that means in Canada, the city that means that is identified for smart city project implementation is Stratford. Smart meters, smart readers, and access points. Now, here that means I just wish to that means share with you is that nowadays that means your enemy that means doesn't do that means make an aerial attack on your country. If it can that means somehow enter into the control room of the your smart grid and just that means shut down all the generators, the entire communication of your country is lost. And so they can do that means anything that means the with your that means the country, because in that case you will not be that means the able to that means establish any communication. So so therefore the most important thing that means the in smart grid is that you need to that means the secure it. It is now that means the as vulnerable as military installation as well or the atomic energy installation. So there has to be that means the adequate that means the security and other things. So the business needs that particular city that means the considered is to meet the energy conservation regulations and stimulating economic growth. Motorola's 802.11n mesh wide that means your wide area network is that means the used for as a solution. Okay, and the companies that are there is Rhizome Networks and flexible hydro are that means are involved in implementing the smart meters, smart readers, as well as the access points. In Singapore, what they have done, the devices they have deployed is cameras, tiny sensors, GPS, and access points and RFID cards to enable the intelligent transportation system. Because the city's mobility management, especially traffic mobility management, dictates to that extent the well-being of the city. If there are too much of traffic snarled or chaotic, that means the traffic, then a lot of that means the fuel is wasted. And this fuel indirectly will contribute to the city pollution level. So if you can make your that means the transportation system smart and mobility that means the more smooth, it has that means the attendant effect of that means the reducing the city pollution also. So the solution that they considered is ultra high speed 1 Gbps nationwide broadband access and wireless broadband infrastructure. Okay. And the companies that involved are LTA and A-Star. And finally, that means for Portugal, the city that means that was identified for case study is Porto. Access points, sensors, and cellular operators. So these are the devices to address the mobility and transportation that means the challenges. So the solution was NetRider, multi-networks on board, NITs, and fiber and Wi-Fi. Okay, Grupo Galmes and Cisco were the company that means the which are involved in implementing the same. In our country also at the first phase, we have identified that means the 100 that means the cities to be considered for smart city applications. Okay, now the work is that means the on, and it's a long and that means the tedious process to identify the vendor, to identify the technology. You need that means the capital, you need that means the money to implement the smart city project. So hopefully that means the in near future that means we will have that means some cities in our country which will also be that means smart cities, and they will also that means come up as a case study in many that means the research domain. So having that means the said something regarding that means the, what are the various kind of technologies that means that can be that means the deployed. So now what are the that means the challenges and the research areas that we have to that means the considered. The number one is the inference interference management. Okay. Due to the unprecedented proliferation of wireless devices, coexistence of devices is growing at a tremendous rate that leads toward interference problem, which causes frequent data communication errors. Interference can impede the successful deployment of sensors, wireless LANs, and other equipments in smart cities. So, interference management is one of the key challenges to ensure these devices are working without facing interference problem. Off-the-shelf interference management models and mechanisms for wireless networks can monitor the extent of interference and provide certain solutions to cope with it. However, these models and mechanisms will not be able to solve the interference problem completely and optimally in smart cities due to the voluminous number of devices connectivity, which makes it quite complex. Therefore, robust interference management services are required about smart cities networks. So this is a great problem. Not only that means the in smart city implementation in locations or points where that means that you have a great many that means the devices which are deployed to establish a communication network. So, uh, so there are a lot of that means the challenges, and we just cannot that means the avoid interference totally. But sorry, but what we can do that means the we can very easily that means the reduce the amount of that means the interference because in case of emergency if the interference that means the causes interference that means the delays that means the data transmission, then the purpose of smart city will be lost. So a great challenge for researchers in smart city project is how to that means the minimize and reduce the interference management. And people are that means the working on this one. So I have a request to the audience, those who are from that means the communication, electrical or electronics, as well as a similar kind of that means the background, can think of that means the exploring the possibility of that means carrying out research in interference management. The second one is what is called scalable, that means wireless solutions. As the futurologists have predicted that a voluminous number of devices will be connected to the internet with the aim of turning the city into a smart city. The need for scalable wireless solutions has arisen. We just that means cannot still today that means we cannot that means foresee the moment a truly smart city will be there. Almost that means every device of our day-to-day life or usage will be that means in a network, and that will pose a, that means tremendously that means the large amount of challenge on the that means the wireless technology. Although the state-of-the-art wireless technologies such as RFID, Zigbee, Bluetooth, LoRaWAN, Z-Wave, and other WPAN already support low-power device communication, their capabilities are limited and in terms of a number of devices, throughput, and transmission reach. Moreover, the modern wireless technologies like 802.11 will also not be suitable for smart cities communication because these are originally designed to offer high throughput to a limited number of stations located indoors at a short distance from each other. Therefore, it is required to pay high attention for enabling smart communications in the smart city environment. So, what is very important, and we as that means the engineers and scientists need to look into that. Once the smart cities are that means are definitely becoming a reality, we will face that means a tremendously that means a large challenge in terms of that means the wireless technologies. So concurrently, we have to develop the wireless technologies, which should be that means capable of meeting the requirement of smart city projects. The second and the most important, the third challenge is interoperability support among heterogeneous wireless networks. Smart city networks are usually deployed using different wireless network topologies, such as Wi-Fi, WiMAX, mobile network, ad hoc networks, wireless mesh networks. However, bringing interoperability among these heterogeneous wireless networks has become a serious concern. To enable the communication among different wireless networks requires addressing the challenges associated with interoperability. This in turn networking of the diverse wireless technologies for efficient delivery of value-added applications and services lead to several challenging issues, mainly related to architectures, resource allocations, mobility management, quality of service provisioning, and security. Thus, it is required to pay considerable attention to addressing these challenges in the future. Since we will be having a diverse environment of that means the devices and technologies, so their interoperability is that means a great challenge, and there are that means a lot of research to be that means carried out. Till now, the smart city projects are that means implemented only in that means a certain specific domain. But if we are to really make a city smart, then we have to that means the upgrade each and every city functionality, and then comes we need to deploy the lot of that means the heterogeneous technologies, and we have to make them that means interoperable, not only in terms of architecture, resource allocation, and etc. So there are that means a lot of challenges in this area also. Okay, so smart cities offer numerous services. The mobility management is that means another issue. The smart cities offer numerous services for the mobile users, such as e-health, intelligent transportation systems, and logistics. These applications significantly rely on heterogeneous mobile technologies and thus demand various services ranging from non-real-time applications to real-time multimedia applications offered by various access networks. Therefore, one of the major research challenges for the upcoming mobile systems is designing of intelligent mobility management technique that take advantage of various wireless access technologies to achieve global roaming. Moreover, integration and interoperation of contemporary mobility management techniques in the heterogeneous access networks is required for the integration of forthcoming wireless technologies in smart cities. So, mobility management is again the great challenging area because until and unless that means we are able to that means make it fully mobile, and the mobility management is that means not built into, then the project is that means bound to fail. The next issue, which is also that means a great challenge for your smart city implementation, is high energy consumption. Due to the deployment of resource constrained devices in smart cities, communication and networking from an energetic point of view have gained serious attention. Although advanced communication technologies, namely, say, WiMAX and LTE, have facilitated the users in terms of tremendous downloading and uploading speed, the energy consumption rate is significantly very high. That can impede the realization of these technologies. While you will be that means using a device which is battery operated, then even though these technologies permit you that means that to go for a very high that means uploading and downloading of data, but you need to that means recharge your that means more than that means once every day, and so your that means overall productivity will surely that means fail. In the future, devices may have high specifications in terms of battery life, but the energy consumption rate of these modern communication technologies will still be considered as higher. The reasons of causing high energy consumption in modern communication technologies are as follows: enhancement of radio network to attain good quality signals, support of multiple parallel transmission, powerful data transmission, to name a few. Thus, future smart cities must ensure control and optimization of renewable energy sources and demand-side management programs by delivering real-time information. So, thank you all. That means for your time and that means the attention.
Thank you. Thank you very much, sir. It was really an informative session covering generic connectivity of different IC and information technologies as per the interest of our Heterogeneous audience. As such, I am not having any query from the participants in YouTube channel. No one, sir. Then thank you very much, sir, for accepting our invitation and for giving your valuable time in delivering a generic talk on emerging areas of ICT in context of a smart city environment. With this one, I invite you, sir, for the valedictory session 2. It is scheduled at 3:30 p.m. onward on 15th January.
Okay, thank you. That means there is there is no question from the audience side.
Hello, I have one question regarding hello sir, hello.
Yeah.
Yeah, this Reddy. Just I'm one of the.
Okay,
So,
okay. Yes, sir.
so I would like to clarify one thing. Just some general question.
Yeah.
Do you think so? This smart city the technology viability depends on the density of the population. For example, Singapore, we know that it's like 40-kilometer radius, so
Yeah.
their density of the population is very good. So sometimes it depends. But I'm talking in terms of viability because you want to put a smart sensor, everything you want to monitor.
Yeah.
So do you, based on experience, density of the population will play an important role, or what are other things? For example, maybe economy also very important. Yeah, smart city means smart sensors. It will cost more. That is the one thing.
Yeah. Okay. Yeah. Okay. Thank you. Yeah. Thank you for the
Okay.
question. It's a very good question. See, there are a multitude of that means the parameters. It is a multidimensional that means the problem. Density is definitely that means an issue. The moment if an area is that means the highly dense, not only in terms of population, even in terms of that means say, buildings and structures. Then what kind of technology you will be developing or deploying will also be important. Because as I said during the presentation, high-rise buildings says obstruct the passage of wireless signal. So you just that means I cannot have the traditional technology that means which can be that means deployed in those locations. One advantage of a densely populated area is that just by deploying a particular that means the device, you will be that means able to service that means many people. Just the way, if you consider that if an area is that means a very sparsely populated, we can say that okay, it's only say 5 people that means live in 1 square kilometer. And if your that means mobile communication your communication technology has an area coverage area of only that means say 1 kilometer, then perhaps that means that you require that means one device to service 5 people, another device to service that means another 5 people, and something like this. If you consider uh, a densely populated city like Singapore as well as Hong Kong, where you will find that in one that means a kilometer, there may be that means tens of thousands of people are staying. So even though your that means the device deployed to establish the communication network will be more in this particular case, but the usage of that means the person's per device will be that means much higher. Okay, economy is definitely that means an important aspect because it requires a lot of that means the capital to be invested over a long period of time. And we have this general that means the understanding that if you buy a mobile phone today, you find that after 6 or 8 or 1 month or after 1 year, it becomes that means the slow. The technology has that means already that means the changed. You need to change it. So high-end technologies also that means the undergo that means the rapid changes. So even though you have deployed technology that means that to implement a smart city project, but you are required to that means to replace the technology that means the periodically. So at each and every instant of time, you need to have that means a lot of capital under your control command.
Oh,
If
okay.
it is not there, then you cannot that means the implement a smart city project, because anything that will come, any convenience that will come will be that means at the expense of that means the something. So here for smart city implementation, we need to invest lot of that means the money to make the life of the people a little bit better. The other option is that if you wish to that means avoid smart city implementation or to migration of that means the people from rural area to urban area, then we need to create more and more, that means the livelihood facilities in the rural areas, so that the migration is, that means the arrested. Any other question?
It is clear, sir. Thank you very much, sir. Thank you.
Yeah.
Very nice, informative talk. Okay, thank you very much, sir. Thank you. Okay, thank you, Prof. Thank you.
Thank you, Talukdar sir, for a wonderful talk. And we are
Okay.
equally thankful of Professor M.V. Reddy from Canada. He is keen interested and still he has not slept because of this lecture. In the starting of the lecture, you are saying that after this lecture, I will go to my bed. Now, Dr. Reddy, please take your rest and good night too. Dear participants, we will start next talk at 11 o'clock after around 15 minutes.
unmute.
Sir, good morning.
Good morning, Taimurji. How are you?
Good, sir. I'm good. What about you and
How is
weather?
cold there? How is cold there?
Crowd is on YouTube link, sir, not in Google Meet.
Oh, no, cold, cold.
Cold weather. Normal like October ending in North India.
Okay.
Yes, sir. But I think in Roorkee temperature will be quite.
Yeah. Temperature is means too cold here.
Yes, sir. Yes, sir. You are nearby to Haridwar, Rishikesh.
Yes.
Okay. Sir, within 10 or 2-3 minutes we will start.
Yeah, doesn't matter. Yes, absolutely done. No problem.
Sir, shall I proceed for session? Professor?
Yes. You can start.
Okay. Good morning once again, dear participants. As a second speaker of today's session, I welcome Professor Dharmendra Singh from IIT Roorkee. Dharmendra Singh received his PhD degree in electronics engineering from IIT BHU Varanasi, Uttar Pradesh. He has more than 27 years of experience of teaching and research. He received various fellowships and awards by the national and international bodies, mainly Monbusho Fellowship Japan, Merit Fellowship European Union, DARD Fellowship Germany, TWAS Fellowship China, IFCAM Fellowship France, PWS Fellowship Brazil, and many others. He worked as visiting scientist and postdoctoral fellow at Niigata University, Japan, German Aerospace Center, Germany, Institute for National Research in Informatics and Automatic France, in Institute of Remote Sensing Application, Beijing, China, Karlsruhe University, Germany, UPC, Barcelona University, Spain, and visited several other laboratories in other countries. He received Best Innovation Award in India Mobile Congress 2017 for development of satellite-based agriculture information system. He has received the Best Industrial Research Award 2017 by Institution of Engineers, Roorkee chapter. He received a Dr. Avijit Singhavi Institute Chair Professor in June 2018 and National Gold Award for E-Governance 2019-20 for outstanding research on citizen-centric service for the project Satellite-Based Agriculture Information System, an efficient application of ICT by Government of India, Department of Administrative Reforms and Public Grievances. Currently, he is working as head of the Department of Computer Science and Engineering at IIT Roorkee and professor in the Department of Electronics and Communication Engineering. He has, started a startup, Dirghadi Technologies Private Limited. He has guided 30 PhD students and 20 are pursuing their PhD and guided more than 66 MTech students. He has published more than 300 research papers in reputed international journals and conferences. He has developed several products like agriculture information system through the wall imaging system, ground penetrating radars, etc. His main research interest includes artificial intelligence, computer vision, deep learning, machine learning, data fusion, ICT, satellite data application, polarimetric and interferometric application of microwave data. With this, I welcome and invite you, Professor Dharmendra Singh, to start the session.
Yes, first you have to, okay, thank you very much, Dr. Taimur. It is very nice to interact with you. And first I can share.
Yes.
Is it visible?
Yes, sir, it is visible.
Yes, yes. So first of all, thanks, Dr. Taimur, for inviting. And it is a very nice, although it is a very tough job for giving lecture online without seeing the faces and all, but it is a challenging, and teachers are known for to accept the challenge. So when I got your invitation to, sir, we are doing something for the ATAL mission for the smart city, and nowadays India is moving fast for developing the smart city. So I thought that what I have to discuss, because a lot of things are available in the internet, a lot of things are going on. But how we can contribute, or what is our opinion, that is a very important to development of a smart city. So in this context, whatever I am going to show here, that is my personal and some opinion, and with the based on experience which I have gained by visiting several universities, India, abroad, whatever. So nowadays, if I ask after in the Corona period, the maximum thing people want on their mobile or on their desktop. So in nutshell, we can say that the smart application. Nutshell, we can say that the just you can start. So in nutshell, we can say that okay, the smart application of ICT, artificial intelligence, computer vision nowadays it has a major role for doing all these activities. I was going through your curriculum, the previous speakers. I have seen that a lot of good topic has been covered, like 5G, need of 5G, and wireless communication. And a lot of things are there. So I thought that then if I talk in Indian context, the two most important thing, first, the solution should be the cost effective and its feasibility. So it should be the feasible, so anybody can implement or anybody can do it. I don't know how many participants are there and what are their background. So as I have mentioned that time it is very difficult, but some first few slides, what I am and my opinion about the smart city. And now I am associated with a lot of smart city also regarding their evaluation process, this process, that process, like Dehradun smart city, Jammu smart city, Kashmir smart city, a lot of things, a lot of places. A lot of things are going on. And in nutshell, I can say that smart management of the various things comes under the umbrella of the smart city. So first few slides, I will be showing you that. Therefore, I have written a glimpse. I will be showing you what is the uh, how we can think about the smart city, and another second part I will be showing that how we can provide a cost-effective solution by using some satellite images or by using some kind of airborne images and all of that. So, and as I have mentioned that I have already started at the Rigadi Technology Private Limited. You can go to the web page and you can see the web page and a lot of products you will be seeing. And this is one of the steps towards the Atmanirbhar Bharat. So, and everybody, I think that everybody has to be contribute to make India as a Atmanirbhar Bharat. So, if I say that what is a smart city, everybody has a different opinion, different aspect. So, what is the need? Why? As I have mentioned that, so UN has already published that approximately in 2050, 9.7 billion by the end of 2050. Almost 70% of population will be an urban population with many cities accommodating over the 10 million inhabitants. As the number grows, I am going to ask you what is the need of the smartness and what is the need of the artificial intelligence and how we can contribute. As the number of grows, we will have to encounter challenges regarding making provision of resources, energy, whatever be the, at the same time avoiding the most important thing nowadays, environmental deterioration. So all these we have to be in a very balanced way. How we have to give the resources to everyone, as well as we have to see that it should not affect our environment. Another critical challenge, administration and the management to prevent sanitation issue, mitigate traffic congestion, thought crime. A lot of things are there. I have just mentioned two, three, but whatever you think. So health issues and household issues. A lot of issues are there. What you can think that, but we have to hit one by one thing, so we can contribute to become to bring our cities or nearby cities as a smart city. And many of these, if I say that the sanitation issues, mitigate traffic congestion, thought crime, whatever we do. One thing is very important. It means we need such a device which can collect the data. If we can collect the data, then another important thing, how we can use the data. Because by doing manual or by doing the classical way, it is not feasible. So then the role of artificial intelligence is very important. And after that, how we can disseminate the data to a relevant person, that is again very important and challenging at a required at a required time. So that time that is there. That time there is a role for the ICT becomes very important. So technological advancement facilitate the new experience for inhabitants, can make their day-to-day life more comfortable and secure. And this is the whole concept. What are the challenges, what are the problem, and how as a technocrats we are seeing the challenge and how we are solving it. Somebody is working to transmit the data in a very high speed, very high packet rates, whatever with other. Somebody in planning, somebody is in another how to gather the data. how to get the information. So different platforms are there. Challenges means it is just because I earlier till yesterday night I was thinking I will discuss about the private because we are working a lot for this artificial intelligence for the cyber security. So yesterday I was thinking because privacy and security is one of the biggest issue nowadays. WhatsApp, this, that. So a lot of things are going on. How we can assure our privacy and our data should be secure. So, but I thought that I am not seeing the people. So then at this time it will be very difficult to discuss what we are experiencing and how. So the technological collaboration application like a traffic and all big. So as I have mentioned that this is the whole game is the big data. And big data, once you start the big data, then analyzing the big data and giving the fruitful output, it is again very challenging. So then this role start. Uh, then this role start the artificial intelligence, how we can manage the big data and how we can provide a better output and a fruitful output as per the user requirement or as per the need of the society. What makes a smart city smart is endless. I am just putting as per urban development vision, integration of multiple information and communication technology, creation of sustainable economic development, high quality life in a secure fashion. So various things are there how we can. So major areas: smart healthcare, smart services, smart logistics, smart waste management, smart energy management, and whatever we you think. So if I say the smart, because I am not seeing the faces, so I used to ask, what do you mean by smart? So smart means there are two words, smart and adaptiveness. So, but both has a different meaning. Smart means according to the environment, according to the changes, which the system should have the capability to change accordingly. So, no need to do no need to do the experiment every day by day basis because you know the data and you will be getting the data in a very random way. So it means we should have such a system which should be the smart enough, means we should have the capable enough to change according to the environment and take the proper decision. Second very important thing, it should be the scalable where we want we can scale it. Key components, technological factors, wireless infrastructure, IoT. Nowadays, IoT, a lot of things people are talking about the IoT, computing infrastructure, human factors. Again, if everything is there, but there is a not enough literacy awareness, then I don't think that the smart city has some very positive meaning or something like that. Government factors, support of government and policymakers. So we should have, so all they have in the ecosystem. So we should have to think how we can club with that. Today's smart city, when 4 or 5 years before it was started, the smart city, then everybody was thinking which city we can take as a reference. So that is again challenging task. Either Barcelona, Singapore, London, Amsterdam. In India, it is some place in Gurgaon, Chandigarh, San Francisco. So because then once we have a reference, what kind of system is required, what kind of waste management, what kind of data connectivity, what kind of healthcare system is required, then we can say that yeah, this is a reference level and we are approaching to the reference level. Now everybody is hitting according to this own. So this is again very challenging to make a standardized. Okay, this much is required to say that this is a smart city or this is near to a smart city or not. Applications that make a city smart, as I have mentioned, that whatever you think, everything is there. Smart manufacturing, smart buildings, smart policies, health environment, smart waste management. Nowadays, this is again very challenging task for the smart cities, and smart transportation, smart farming. I will today. I am much more. I will be focusing about the smart farming, how to minimize the waste and to increase the income of the farmers or income of the people who are living near to urban areas. Smart grid, smart traffic management. So whatever you think, it comes under the umbrella of the smart. So for example, you can see that smart traffic management nowadays. This is some uh, 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 image of the Los Angeles based on the computer vision. You can track the car, you can say the because nowadays a lot of sensors are there. I am not going to, because earlier I was thinking to, because we are working with anti-collision radar and this that, so we are thinking that the parking for parking, how the RF and microwave can be useful for the parking and all. But I thought that just give you a glimpse what are the things are there, and then it depends upon you how you are going to contribute on that. So you can see that, and but this is a Los Angeles scenario. If I am not showing the Indian scenario, then it is a big challenge. If we want to do something like that, if our Indian scenario, then how we can proceed. So that is a challenge, still challenge, how we can proceed, how we can see the traffic, how we can see the condition, and then according to that, the smart light, traffic light should be there, so automatically take the decision where should be free or where should be the not too free. So you can see that. So because that's mentioned, data feed from cameras. Means I am involved in some smart cities. It is a very tough job because a n number of data are coming, and then how you can process it and how you are bringing some fruitful information. Waste management. Some cities have started the waste management is still in India. We are thinking about that because waste is one of the biggest challenge. So you can see that for Barcelona, as I have mentioned that if, before going for a smart city, so you can see that. For example, Barcelona waste management system. So in dustbin nowadays, a lot of IoT devices there. It is filled, and then automatically signal goes to the cloud, and and then automatically the vehicle will go to clean this one. So a lot of things are going on. A lot of concepts are going on, and maintain the separate bins for paper, plastic, glass, a lot of things. So waste management. So therefore, I have mentioned that first we have to make some standard. Okay, this is minimum requirement, and the basis of that we can say that we are going towards the smart city. Just giving the name of the smart city, we will be not having the smarter one. Smart lighting again. So again. The use of smart lighting lamp post can be fitted with additional sensors or serve as a Wi-Fi, because nowadays uh, people are thinking, and it is there also, that lamp post can be work as a Wi-Fi network hotspots. So and then you can use it, and one there is a communication between one lamp post to another lamp post or nearby the things, and then according to that you can manage the light, light and the power, whatever be the things. So network of Internet of Things. Nowadays, this is again a very fancy word. Internet of Things, people are moving fast, and I don't know how much we're very careful where we can use it and where we cannot use it, because the problem with this is the managing the power. So this is a very challenging task, but so smart wearables, smart sports, smart health, smart homes. Nowadays, we are seeing that Fitbit is there in mobile, and several apps are there where we can see that our blood pressure, blood sugar, whatever we are things. So, but everything is there, but we should be very careful that devices should not run to us. We have to run the device. So this is the nowadays cat rat race is going on. Who will win the job? So, for example, WhatsApp, you are seeing that the WhatsApp should not handle our life. We have to handle our life our own. So that is our responsibility. Where to use, up to what level we have to use. Uh, so sometimes, so that is a more important. And otherwise, after 10 years, maybe or 15 years, it will be very difficult to recoup that one. AI for IoT and smart cities, as I have mentioned that. If we have a very big data and if we have a very big thing, then taking decision on the basis of the dynamic of the data and the real time, it is a really very challenge. So therefore nowadays people are thinking the use of AI. So there are two groups of AI. One is the people are thinking ethics for the AI, up to what level we have to use the AI. So that is a very important for the our developers. So and then where to use the AI. So you can see that this big data, artificial intelligence, IoT means all are in circle. So train model, decision making, command, collect, again the thing. So their sensing is the most important thing. So either it is based on the IoT, or it is based on the satellite, or it is based on the airborne, or it is based on the balloon, or nowadays people are thinking to fly with drone. So it doesn't matter. Sensing is sensing, how you are sensing, and then ultimately aim is to make a good decision in interest of the country, interest of the society, and in interest of the people. AI-enabled systems, you can see that data acquisition, feature extraction, then pattern recognition. I am not going the details. I will showing some details on that. So these are some very common features, which is very important. What kind of features will be there? What kind of pattern? What is the pattern on that feature? And then the decision, and the prediction. Two things are there. So this is the very important. So you can see that data collection, information analysis, fault model matching, execution. So fault location for example, any anomaly detection or any decision. So controller, AP splitter, terminals, and you can detect the fault. So this is the some very basics for the smart cities. So you can see that AI is a combination of the machine learning, big data. So any image voice recognition, resource management, energy, wireless, security, planning, whatever. It depends upon your cleverness, because nowadays I am seeing that people are trying to use the for optimizing the communication also. AI, in a lot of places people are trying to use the AI also, so that they should have to know that which band or which channel is free or which is less congested or whatever they think. So according to they can switch to in that channel. So as I have mentioned that after that, after the brief of the AI, I will be trying to focus how we can do the smart land cover management. by using the AI. And another very important thing, once we are saying that the land cover, because for planning the city, the land cover management is a very important. So and then I am just going to show you some glimpse that how precisely we can work or we can smartly detect any changes or any enhancement in a particular area or particular field. Another very important thing, if I say that as I have mentioned in the beginning, the cost-effective solution. So we always have to think that our solution should be cost-effective. And second thing, I have mentioned that the feasibility of the solution, either it is feasible in real scenario or not. So as a technocrats, we have to as a technocrats as well as for Indians, we must have to think about that. So today I am just focusing how with the satellite-based platform we can effectively use to plan the city, to plan the agriculture field, and then take the decision according to the requirement. So agriculture, health, I have already mentioned that for a better world, mobility, robotics, security, health, so better world, reform of agriculture by artificial intelligence. So you can see that I am just showing the one example. Uh, Shift in agriculture, but this is the, you can see that this is the, I have mentioned the shift in agriculture, but nowadays, once we are talking about the industry 4.0, then all the devices should be smart, all the devices should communicate to each other, and then all the devices should communicate to the controller. This is the main requirement for the industry 4.0, and accordingly, a decision can be taken. So you can see that the what was the technology at 1840, 1940, nearby 1960, third revolution, and now we are moving towards the fourth revolution, towards the AI to make the decisions in a not in a not in a classical way, but in an automatic way, according to change, according to the seniority. We can say that. You can see that third digital revolution where IoT different sensors are there, different things are there, but all they are not communicating. All the data were not collected at one place, and according to that, if I say that, for example, for irrigation, so automatically if some sensor is there, and we are seeing that there is some lack of some moisture or water, so automatically the pumping set should start and stop. So it will reduce the human cost, but we have to take care. Either we are going to reduce the job or we have to. That I always used to say that it depends upon how we are dealing with that. So artificial intelligence for agriculture innovation is the inevitable course. AI-driven agriculture platform. You can see that I have already mentioned that the data, features, pattern, analysis, then our this one. So you can see that the crop digitization, commodity farming, AI analysis, and we can get the best crop match, just in type crop production, environmental enrichment, new business seeds, whatever be the things, according to the combination of one and two, and we can get after the artificial analysis this one. Nowadays, again, as I have mentioned that this is a one step for the smart city, how precisely you can observe the things. So therefore, just I am showing one data, how, for example, you can see that the wind erosion, soil erosion, runoff, chemicals, these, that, whatever be the things. So you can see that how we can map the terrain, soil, yield, fertilizers, and this is the whatever we the satellite images. So how we can slice each image and how we can get the information according to the requirement of the different conditions of different things. Already I have mentioned that data science and agriculture, you can see that data from different resources, different and how it is going to cloud. And then you can see that how it is going to cloud. This is some Europe. They used to put a lot of sprayer, and automatically it is going to spray the things. Okay, either it is a whatever with the thing. So you can see that here it is the customers. So whatever be the different channels or whatever be the different players, we can connect, and then we can provide the suitable example, suitable decision according to the need. So now after that, for what purpose I got the gold award and other awards? So I am just going to show that how in a very, very clever way we can do the macro to the micro scale monitoring using the satellite images. So so a lot of things are there. I am just saying that whatever a lot of policies are there, a lot of things are there, but sometimes it is unreachable to the end user. So it is our responsibility to send the actual information to the end user. You can see that agriculture information system, which is a so similar way we are trying to develop the smart city information system where maximum data, maximum type of data you should be in your mobile, and you can see that now. Once you are seeing this Google map also, and then you are seeing that what are the traffic, what are the things, a lot of things you are getting the information. But a lot of things means still, except traffic, a lot of ways. Means, for example, healthcare, where the positions are available or what kind of things are there, and education system where the schools are going on, what are things are going. A lot of things you can make it very important. So, so as I have mentioned that freely available satellite data, real-time information of crop like health, disease, micro level to the macro level, and then the web-based and SMS-based service means if something is happening. So here you can monitor, but every time you will be not opening your web service or mobile. So if something happens, then there is a facility of the SMS service. SMS will go to the automatic to the district authorities or whatever with the authorities, and they can see that what are the things are there and what are the changes are there. So develop agriculture information system, real-time information, information to the end user in a cost-effective way. SMS emphasis for the low-cost satellite data or freely available satellite data. And for example, what we have used, that we have used the freely available satellite data. What are the salient features, which I am going to show that how the land cover monitoring, if there is any change, if the crop health means real time, you can see that the crop is the most dynamically changed target. So how we can measure the changes in the crop in 1 week means you need, if you will talk in the terms of RF, you need a very high sensitive device or very high sensitive algorithm where you can have a capability to detect the changes in something somewhere in 10 to the power minus 2 or 10 to the power minus 3, something like that. So features, so as I already mentioned, whatever, I am just showing some of them, whatever you want, you can see, and we have the capability, we have already developed it, it's running very nicely, and you can see in your laptop. Benefits to the society, economic planner, health sector, land management, land advisor, so on. Whatever you want, you can do it. As I have mentioned that, the same concept for the smart city, data sensing, data coming to the center, then the data analysis, part of the AI, and then it is going to the, it is all these things should be done in the cloud and disseminate to the farmer, disseminate to the mobile, whatever be the device. So you can see the different locations from the different, they are able to see the real time. The important thing is the in a real time scenario or very less lagging time. Technology which is used, data mining, AIS and artificial intelligence. So different type of things are there which you can we are doing for that one. You can see that the implementation of agriculture information system, as I have shown that this is the data from the NASA center, and then automatically everything is automatically, now we have the millions of data of the country for different locations. So application server, data server, and then the web server. So all they are interlinked, and so you can see that data download, mosaicing, resampling, cropping, crop data stored, and then I will show you one real-time example. User query, fetch data, crop location, whatever with the greenness, whatever with the display, so web server, application server. So this, all these things we are doing on the cloud, and then you can see on your web the display of the your required this one. Just to make understand, because nowadays so there are two type of sensors. So passive sensors, once we are using the IoT, also IoT is a sensor. So making the sensors, so two type of sensors are there, passive sensors. So if you see that passive sensors are here, the sun is the source of illumination, and whatever be the things are there on the earth, it is reflected and uh, illuminated by sun, and then after reflection, it is going to the satellite. And after the satellite, we are receiving the data at our receiver station, and then from there we are taking the data after the after the process data, some zero first level data or the zeroth level data without processing. Whereas the active sensor, which is known as the based on the radar technology, where where a sensor is emitting some energy, and means here source of illumination is sun, here source of illumination is some energy emitted by the sensor, and then that energy interact with this target and again going back. So if we can, if I say that what is the passive and active sensor, so main drawback for this passive sensor is that if sun is not there, if there is a cloud, if there it is in a visible near infrared thermal range, and if there is a cloud, if the night, then it is very difficult to sense the target. Whereas this is the radar wave, means that working on a microwave from 1 to approximately 30 gigahertz. But generally, people still we have a sensor up to the 1 to 12 gigahertz or 14 gigahertz only. So here there is a no hindrance due to the cloud or due to the night or due to whatever be the thing. So this is so if we'll say that making this sensor, and this sensor has, if I say that we want the information sensing. So sensing has a two very important aspect. One is you should have the availability of the data, means you can get the data as I have shown that. Second thing, the resolution of the data, how much resolution you are getting. So this optical sensor has a very good resolution, very cost effective, whereas the radar based sensor is a little bit costly, but both are giving the complementary information. One is the day, one is the night. So if we have the multi-sensor data, then very effectively we can use the city planning and city planning and city changes if they are without any human intervene. So you can see that the different survey on the field, survey after 1 year, you can see that. So in real time, how we can change it. So it is very difficult. So traditional mapping, basic aerial photograph interpretation is quite cumbersome. So there is a need, such need, where we can do all the things with a remote access. So just I am showing that if I am saying that the sensors, so what the kind of sensors are there and what are their importance, you can see that the red channel in near infrared, blue, green, near infrared, they are the spectral bands. And these spectral bands has their different importance. As I have mentioned, if you remember in third or fourth slide, the features. So these channels are work are used as a features for any AI system, and you can see that if it is a red, so what kind of things are there? If it is a near infrared, so vegetation land cover transformation, blue soil vegetation, green vegetation. So different according to the need, you can select the different bands, and that bands will act as a feature, and that feature that for example, for the waterland, for the urban areas, for the residential areas, they have a different pattern, and according to that, you can make, you can correlate the pattern, and you can say that yes, this is the same thing, or this is the things are going to be. Then a lot of things are roaming around us. It is our cleverness how effectively we are going to use it. So this is the zeroth level data, means we have a reflectance value, and this is the data derived from the zeroth level data. You can see that different vegetation indices. I have just mentioned because I am focusing for this one, but you can see that this normalized difference built up index NDVI. So this index has some estimation of building structures, estimation of building structures, and estimation of building structures and other things. So by using the different burn area index, this, that, so a lot of indices are there where it will act as a feature. So as I have mentioned that spatial resolution, spectral resolution, temporal resolution, three things are very important while monitoring anything in a real time or in a very dynamic way. Spatial resolution means what is the resolution cell at the ground. We are knowing that it is a sometime it is a 1 centimeter by 1 centimeter, 1 meter by 1 meter, 1 kilometer by 1 kilometer. Spectral resolution I have already shown you. These are the spectral resolution. So how pure is that? For what purpose it is there? So and then temporal resolution, how frequently it is passing from the same area to the same area. So how frequently we are so all these things are there, but some sensors has a passing from the same area after 14 days, some has a 7 days, some has a 6 days. So again, it is a very challenge if we have a different sensors, so how we can bring them in a one platform, so that we can have a regular basis data or daily basis data, whatever. So this is again a very big challenge for the using the different sensors. So spatial resolution, pixel size already I have mentioned that. Fine spatial resolution image. Nowadays everybody is using the mobile. I don't know. So 40 megapixel, 30 megapixel, whatever be the things. So coarse spatial resolution image, large features identification, spatial resolution degraded. So if resolution is poor, then we have not a very finer information of the particular area or particular location. So different satellites are there like a Landsat, MODIS, NOAA, LOS, Pulsar, radar satellite, RadarSat, RISAT. You can see that temporal resolution is 16 days, MODIS has 1 to 2 days, but here spatial resolution is 30 meter, here spatial resolution is 250 meter. So here spatial resolution is 1 kilometer, but temporal is very good. So data are available. You can see that here this is the radar set data, radar technology data, 46 days, 25-meter resolution. So a lot of data are available. Then again, it is a very big challenge how we can use effectively for these data, because bringing the data in a same scale, same platform, a lot of challenges are there. So just I am going to show that how to start adaptive land cover changes and the AIS agriculture information system online, how we have developed that. So just I am showing we have developed n number of models, enough expertise for mapping the land cover. So, but here I am just showing that the models data, how we have started, how to select, because for artificial intelligence, the two things are very important. Your input should be as pure as possible. Otherwise, if your input is not uh, in a good shape, then it will hamper your output. So always the input should be very important. So therefore, I am just going to show that how to develop the algorithm with that. You can see that challenges, different line cover classes show similar gray values, difficult to separate one class from other. And this optical data suffers from the atmospheric disturbance features. So feature extraction and line cover interpretation is a very, very challenging task. Challenge, as I have from the very beginning, I am mentioning because I used to fight for a very cost-effective solution, whatever be that, and I am taking the cost in a three ways. First, the time. Second, the human power, human manpower, and third one is the cost of the device. So the computational complexity, the temporal complexity, and then the cost of the device or cost of the things. So identification of land cover classes without having any a priori information. That is the biggest challenge. If you do not have any challenge, I am not going to show this one. Otherwise, we have done a very good work for the Chandrayaan-1 mission also, where we have observed the possibility of the water ice on the moon. And moon is just like we don't have any ground truth. So moon is just like a black box for us. So, but here, so modest data already I have mentioned that spatial resolution 250 meter, 500 meter, 1000 meter. It has a 36 spectral bands. As I have shown you some of the bands, near infrared, red, blue, green. And the most important thing is the freely available data and temporal frequency is 1 to 2 days. So concept, how we can start. So because there are different colors in our city, so we have thought that we have to go for the color shades. So how to change in the color set? So we will see that how sensitive the color sets are there for a different classes. So color set has more discrepancy than the gray values, which form the comparative contrast among the bands. Could be extracted by rendering the pseudo color composite image. Color features inherent various amongst the chromatic and achromatic properties. So as I mentioned, the different colors of the land and then how we then this is our cleverness, how we are assessing at the different color labs. To explore the applicability of modest composite data for land cover monitoring by color feature extraction, to propose adaptive, as I have mentioned that this should be the smart enough or adaptive enough, so it can work for in a different places or different conditions or whatever be that. Methodology, image pre-processing, selection of bands. So if you remember the second slide or third slide, selection of band, conversion in the different features, color models, analysis of the color model. This is the most important thing, the data analysis part. Then this is the pattern recognition part, what kind of pattern is there, and then ultimately the decision tree any algorithm which have to be for the output, for knowing the for getting the fruitful output, any algorithm you can use. But here we have, because we have used the decision tree classifier to use this one. So you can see that this is the study area. This is the nearby Muzaffarnagar where we are. This is the Roorkee. This is the Saharanpur, Panipat. So big area we have taken. This is the Meerut. So big area. This is the satellite image. This is the Google Earth image for different part of the country. So you can see that this is the satellite MODIS image. So how we are changing, the different processes are there, because the most important thing to get the coordinates of all corners, so we can have a exact location. You can see that it is well coordinated. Then you can see that selection of band and indices for a different bands. If you remember this image is the Google Earth image, and this Google Earth image has a certain limitation because we don't know at what time, because a regular interval it is not changing. It has some change in 6 months, 3 months. So regular monitoring we cannot do this one. But you can see that red band, infrared band, normalized difference vegetation indexes, red band 6, NDFI band number 31. For the same location, the different bands are giving the different information. You can see that the bright one is the that is highlighting the information. So these are some cities. If you remember, if you see here, so these are some cities. This is some cities. So very nicely with the red band we are seeing, and this is some water bodies or something like that. So the purpose is that the different band has a different information. Here only with band 31, this is the thermal band. Only we are able to see the city behavior or something like that. So so different band has a different information. So how we can use effectively the different information. For example, if you see that this information is here, but this information is not here. So how we can effectively use and this information is here, and but this information is somewhere missing here. So how we can effectively use the different information, that is most important. You can see that this is the pseudo color image generation band 2 and DVI band 1. You can this blue color represents the water bodies, red color represents the urban, green color represents the agriculture area. So you can see that, and if there is a mixer, yellow color means green and band means we are getting the reflectance in between that. So this is the yellow color that shows the some bare land or something like that. So different kind of color compositions we are seeing. So it gives what it gives. What does it give? It gives a a, a concept, a thought that yes, different land covers are there. So we have a different variability in a different bands. So that we can use it and we can make a decision support system by which anybody can get benefited with that one. So color features, you can see that researchers in past revealed that different color space, unique perspective skill for pattern identification. Each component describes different aspect of chromatic and achromatic information, as I have mentioned that. So color space, for example, physiological inspiration based, RGB, physical and technical based, YIQ, perception based, HSL, Scilab, uniform color space. So these are some. So they have a different physical significance why we are going to use it. And you can see that. So this is the how we are calculating the hue, how we are calculating the lightness, saturation, L, A, B. So different parameters are there, and significance where it is giving the significance. That is for considering the features. This is one of the most important things because computer does not know what is X, what is Y. So we should have to know that until unless there is not a physical relationship between the output and input, or there is a not dependency on the output on the input, we should not have to give the data as the input. Otherwise, computer does not know, and we are knowing that artificial intelligence, this is the biggest challenge, artificial intelligence and the machine learning, garbage input, garbage output. That we have to take care for that. So you can see that first very basic. Uh, I used to say to all my students, this is the first is important decimal. You can see that this is the RGB for water. How it is going to give the difference, because blue is changing, but RG are overlapping. So for the different LAV, for the different color space, a exhaustive data analysis is required, which will give you the confidence. Okay, for example, here in LAB, so A in the color space, A is a very good for differentiating between the dense vegetation to the other one. Otherwise, this L and B are giving the approximately the same behavior. So this gives a type of sensitivity analysis. Okay, Science has a capability to sense the dense vegetation, normal vegetation, bare soil, water, urban, whatever. Here you can see that here it is very difficult to get with HLS. We are not getting the bare soil information very clearly. So this gives this one. So you can see that for the image 1, we have done, for image 2, we have done. And then we have make our some models, what is required. On the basis of that, you can see that on the basis of that, B should be greater than R, YQ should be greater than Y, Q should be greater than I. So this shows the urban, this shows the water, this shows the bare, this shows the normalized. So class color space. So it gives the idea what should be the minimum requirement that we can have some identification of the target, like urban, water, whatever be the target. So attributes, as I have mentioned, that different attributes, we have taken the some ground truth information, the number of pixel of class 2. So this is the information, this is the guinea game. So this gives the all these analysis we have to do, because this will give the whatever with the data you are taking it is okay or it is not the okay for the further processing. So on the basis of that, we have make a decision tree classifier algorithm. This is this is the just first concept. Yes, this is the RGB, and this is for the bare soil. This is for the water, this is for the urban, this is for the unclassified, this is for the dense. So what is the conditions for the different color space? Then we will be having a decision support system where we can identify the different aspects. You can see that very nicely we have identified this blue color is the water bodies. This is the somewhere in Saharanpur I have shown. This is the urban. Water red color is the urban. So very nicely we have identified the target, what are the things are there. So you can see that this is the total confusion matrix, how percentage approximately. You can see that 67, 97, 79. So different means more than 75% accuracy for the different classes we have achieved for identifying this one. So on the basis of that, we have developed our own agriculture information system, which has the fusion of algorithm for the radar data and the optical data and active and passive data. And then you can see that this is server, this is SMS based, web based information to the user. I will be showing you some end use case. So you can see that the classification here, as I have mentioned, that pseudo color, selection of ROI, selection of color, model component, development of decision tree classifier, and then so you can see that the pseudo color generation of this particular area, as I have shown, selection of ROIs, we have selected for the verifying the result and for training this one. Extraction of color model, different color model, RGB, HLS, YIQ, Scilab. Analysis, we have already, I have shown you the analysis, how we have done and how we have made the decision tree classifier. And then we have developed a decision tree classifier. You can see that this is the complete flow chart. So yellow color, urban, bare soil, urban, water, unclassified. So on the basis of the very critical analysis of the different features, so we have developed our algorithm for this decision support system where we can very easily detect. You can see that high, dense, normal, a lot of variations are there. So this type of variation we will be able to see that. Then this we have proposed, we have applied on the cloud server, SaaS, PaaS, and IaaS. So server, storage, network, and cloud is provided by the Geo. So we are using the Geo cloud since last 6-7 years, 5-6 years. So data management system, and then here it is a GUI. I will show you development of application for agriculture and then browser. You can see that this kind of result we are getting. This is the, for example, 2016 Uttarakhand area. Uttarakhand area, and you can drop down menu box is there. Select the Haridwar, and you can see that in 2016 at the 25th to 1st February, what was the condition in 2016, what was the condition in 2015. So this gives and this is the greenness. You can see that if the greenness value is from this to this, if you will put the cursor, you will get the values for the different location if you want, and then you can zoom it. Now, this is the map, so you have all the information. If you want, you can collect the information from the various locations. So very fine information you can observe, and you can see that either there is some change or what kind of things are there or what kind of problems will be. Second very important thing for the smart city or for anything, what was the condition, for example, weather condition, what was the traffic condition, or what were the things in the last 5 years, for the same week. So you can see that in this for example, I have taken one example in January, this one. So last 5 years, 2011, 2012, what was the condition there? Then again, it has a very good capability that you can, whatever you want, means if you want the whole year profile, you can see that whole year profile, how in the place of Haridwar, the greenness is changing. So according to that, greenness is one of the major effect on your any smart city. So you can see that if it is the greenness is changing, then we have to see that what are the reason why greenness is changing a lot, or why greenness is changing in a different years. It was, for example, you can see that greenness up to that, but in that particular year it is reduced. So we have to check that why it is reduced, due to the less rain, or due to the cutting of the tree, or whatever be the thing. So a lot of factors are there. You can see that this was for this one, for the district level, and if you will go for the for example, it is again for the Dehradun level. You can see that for the Dehradun also, means whatever we, for 6 or 7 districts we have opened it, and you can comparison. You can see that you can see that the difference 0.474, 0.478, 0.544, very minute differences we are able to compute. We are able to see that, and according to that, you can see that what kind of changes are there, because there are two things. One thing is that your detection, and second thing is their cure. So 3 things always there: prevention, detection, and cure. So we are working for early detection of the things, if anything happen or anything is going to happen, then how it is going to think, sir. For you can this is one of the most important thing nowadays. You can see that very precisely. This is the Haridwar region. So 2012 and 2011, what is the total agriculture area? This one. And in 2011, it was 1,694 square kilometer approx. Urban and water area, and then it is here. It is in 2011, urban water area was more. Here it is less. And we will be seeing, I will show the next slide, it is the most important. You can see that the blue color is a positive change where the agriculture becomes urban, and the red color is the negative change, and green color is the no change. Negative change means the area where previous agriculture was not present. So you can see that how precisely it is going to help how much land it is converted from the agriculture to the urban areas, or what are the changes in the urban area, and what are the things. So validation, so a lot of validation we have done for the different places. Then for a city, the water problem is very much, we can map the drought area also, how the drought is going to affect, and what was the condition in the 2016 or 2015 or whatever be the in the previous map. So again, this is one of the most challenging tasks which we have faced, because now we have developed the technique. You can put a cursor anywhere, and cursor has a cursor means our pixel something like between 500 meter to the 1 kilometer by 1 kilometer, and then you will get, for example, we have put the cursor here. We have to get all the information what we have mentioned in the area. So it is already we have executed since last 2-3 years already. It is running, and a lot of beta testing is going on in a different place. Benefits: better decision making, improved communication, managing geographically, better geographic information. So improved transparency, that is one another important thing. Identify at risk under the served area. So infinite facilities are there, so we can use this one. So various coverage, various this. So thanks to the Railtel, Reliance, several students, and thanks for, this is the website where you can see that, and thanks for the patience. If you have question, we have enough time, 10 to 15 minutes. I will be happy to answer the question. Hello.
Thank you very much, sir, for a wonderful session connecting ICT, artificial intelligence, and smart cities. Let me see some queries on the chat box of YouTube channel. Yes, sir. Will IoT actually works over its own dedicated wide area network?
Please repeat.
Will IoT actually works over its own dedicated wide area network?
Yes, it can work.
Okay.
Means IoT, Internet of Things, means it is your cleverness, how you are bringing the different information in a platform where you can observe, you can analyze, and you can see. Okay. So either it is a wireless or wired. People are preferring the wireless because some places it is a wired one. If it is a closed network, so it is a wired one. We are seeing, for example, the CCTV. So a lot of CCTV cameras are there. So all it is in a closed network. So whatever be the things are there. So whatever be the data is there. It is because today I have not put all the things because I was not knowing what kind of audience are there. Otherwise, I can show that this is the means people are thinking the IoT sensor. We are thinking the satellite is a sensor, and then we have given a new term, satellite-based IoT. So because no need to put a lot of sensor, a lot of places, you can use the cleverly because putting the sensor at one time, it is not a big deal. Maintenance of the sensor is the biggest challenge. How you have to you can have a maintenance because the power backup is required. Stealing, somebody can steal that sensor from the different fields. So that is a very important. Yes.
With this, we all are thankful of you, sir, for accepting our invitation and for giving a wonderful multidimensional research opportunity to our participants. Now, I invite you, sir, for valedictory session 2, which is scheduled on 15th January
Okay. Okay. Great.
at 3:30 p.m.
Okay. Great.
To join with the same Google Meet link.
Okay. Okay. Good.
Okay, sir. Thank you, sir.
Okay, Dr. Taimur, thank you very much.
Okay, sir. Bye, sir. Now, the second, last session will be held at 1:30 p.m. Prior to that, we can have a break. I see you at 1:30 p.m. for third session of day 4.